Hi ladies, are you tired of razors, hot wax, and harsh chemicals to remove unsightly body fuzz?
Well, not anymore. Try electrolysis.
Come on down to Miss Rose's chemistry room and we'll shoot electrical currents through your hair follicles to get rid of that body hair.
Isn't that inviting?
Well guys, I think you're confused about what type of electrolysis we're talking about here.
Oh? Then what's electrolysis then?
I don't know, but I guess we can all learn about it together.
Electrolysis is the use of electrical energy to bring about chemical change. How it works is the material to be electrolyzed is contained in an electrolysis cell. Ions must be present in the liquid or solution for a current to flow. The movement of ions within the cell constitutes the electric current. The cell has two electrons that are connected to a source of current. If the voltage is high enough, chemical reactions occur at the two electrodes. Reduction occurs at the negative cathode and oxidation occurs at the positive anode. There are two types, electrolysis in molten salts and electrolysis of aqueous solutions.
I know about electrolysis of molten salts. For example, in the molten state of NaCl, Na plus and Cl minus ions are freed from their crystal structure. If a potential is applied to the electrodes, Na plus ions are attracted to the negative electrode and the Cl minus ions are attracted to the positive electrode. If the potential applied is high enough, chemical reactions will happen at both electrodes. But remember, this does not happen spontaneously. The energy for this reaction is provided by the electrical current.
Oh, I get it. But what about electrolysis with aqueous solutions?
The idea is generally the same, but this is a little more complicated because water can be oxidized or reduced in the electrochemical process. In other words, it's electroactive. Let's do a demo to help us understand it. Okay, here we go. As an example of electrolysis in an aqueous solution, here's a demo.
Wait, what supplies do we need for this demo?
Don't worry, I got everything we need.
Okay, perfect. In order to do this demo, we need a clean petri dish, 2 connector cords with insulated alligator clips on both ends, 2 pieces of graphite pencil lead, a 9-volt alkaline battery, 500 grams of anhydrous sodium sulfate, 120 milliliters of Bogen universal indicator, a pipette, a spatula, and 3.8 liters of deionized water.
Once we have the materials, we can begin this procedure by filling the petri dish with deionized water until the bottom is totally covered.
Next, add 0.5 milliliters of the universal indicator to the water and swirl to mix.
Then, use the spatula to scoop a small amount into the water and use a stirring rod to mix the solution until the solid sodium nitrate is completely dissolved.
Attach one end of each alligator clip to each terminal on the battery.
And lastly, place the tip of each pencil lead into the solution in the petri dish. Move the lead pieces in a circular motion once in the solution to make the color changes more visible.
At the end of the demo, you can see the two products formed by electrolysis in violet and red.
Wait, I'm a little confused. What just happened? Well, when a charge is applied to water containing an electrolyte, the electrical energy causes the water to decompose into its chemical parts, which would be hydrogen and oxygen gas.
The balanced equation is as follows.
2H2O yields 2H2 plus O2.
Here are the two half reactions. The reduction, which occurs at the cathode, is 4H2O plus 4 negative electrons yields 2H2 plus 4 OH minus ions. The oxidation, which occurs at the anode, is 2H2O yields O2 plus 4H plus 4 electrons.
The above reaction is a reduction-oxidation reaction because hydrogen is reduced in the reaction from +1 to 0, and oxygen is oxidized from -2 to 0. Oxygen is the reducing agent and hydrogen is the oxidizing agent.
Oh, I get it. So adding the two half equations gives you the combined overall equation.
Exactly. And in the experiment, reduction of hydrogen occurs at the cathode, the pencil lead electrode connected to the negative battery terminal, and oxidation occurs at the anode, the pencil lead connected to the positive battery terminal.
The electrolyte in this activity is sodium sulfate. The salt dissolves in water to form sodium and sulfate ions, which carry the charge between the electrodes.
So basically, when the experiment begins, the solution is green because the sodium sulfate solution has a pH of 7. As the reaction progresses, you will see violet color develop in the cathode as hydroxide hydrogen ions form and the solution becomes acidic.
The electrolyte in this activity is sodium sulfate. This salt dissolves in water to form sodium and sulfate ions, which carry the charge between the electrodes.
So basically, when the experiment begins, the solution is green because the sodium sulfate solution has a pH of 7. As the reaction progresses, you will see violet color develop at the cathode as hydroxide ions form and the solution becomes basic. At the anode, you will see red color as hydrogen ions form and the solution becomes acidic.
Thanks for learning about electrolysis with us!